Continue along. In C, we have the function y equals 3. Again, we're going to do the same thing. Let's go through a list. Our number one issue is, do we have a fraction? And the answer is no, so I'm not even going to worry about it. Number 2, do I have an even root? Well, I don't have that either, so I'm not worried about that. So I have none of my mathematical no-nos, so my domain is negative infinity to infinity. And this is a really important idea, and we're going to keep on coming back to this. We are going to test you on 3 out of 5 of your tests on domain. It will be no different on test 1 as it is on test 3 or on test 4 or test 5. It will all be the same and on the final exam. And then you'll see it again in college algebra. And again, it won't be any different. So it's easier if you just learn it now. It's not going anywhere. Let's take a look at D next. In problem D, notice we've got y equals 1/2 x. Now notice that this means that if we were to rewrite this, the x could go on top of the fraction. So it'd be 1x or x over 2. Now that means we do have a fraction. The issue with fractions, though, remember, was that we don't want our bottom, our denominator, equaling 0. Well, notice that our denominator then is the number 2. And the thing where you could possibly make something 0 is the x, and that's on top. So even though we have a fraction, it can't actually make our bottom 0 because the x is on top. So it's not a worry. Even though we have a fraction, it's not a worry. It won't cause us any issues. The second part is, do I have an even root? And the answer is no. So, despite the fact that I have a fraction, it didn't cause me any issues. I don't have any even roots, so I have no issues to worry about. So my domain will be that I can plug in anything I want, which is negative infinity to infinity. I found out I wouldn't run into any issues. So I'm done. Let's take a look at E. In E, I don't have any fractions, but I'm popping up with the second problem. I do have an even root. How do I know I have an even root? Is because I have a square root. Remember, whenever you have a square root, there's a hidden 2 there. So that's why it's an even root. And with even roots, we're worried about whatever's on the inside being greater than or equal to 0. So whatever's on the inside needs to be greater than or equal to 0. Well, what's inside is the 5x minus 6. Being greater than or equal to 0. And so to solve that, what we would do is we'd add the 6 to both sides, though that would get us 5x is greater than or equal to 6. Then we'd divide both sides by 5, which would get us that x needs to be greater than or equal to 6/5. The problem is, and we learned this on your last sections for your last test, is you cannot leave it this way. This is why if you go back to the previous page, it asks for the domain specifically in interval notation, meaning you cannot leave it with the greater than or equal to. You have to actually draw a picture and figure out what this means. So let's draw a picture. Here's our 6/5. Remember that we have a greater than or equal to, which means we're going to point to the right because it's greater than. The equal to, though, means I'm going to have a bracket pointing to the right. So if I read this graph from left to right, as we learned to do this for your last test, it should start with a bracket at 6/5 and continue towards the arrow, which means we're going forever to the right towards infinity. Remember, just like before, infinities always use a parentheses. But that is it. That is my official final answer of my domain here. And it's in interval notation. This is what they mean by interval notation.